Hello and welcome to Computer Tech More. This video is going to be my testing methodologies and some of the fans I'm going to be testing for performance characteristics. So I'm going to cover how I'm going to test the fans, so my test setup, the reasons behind the test setup, and everything else, and it's all going to be timestamped down below. But in the first roundup, I'm not going to have all these fans. That'll be kind of too much for me in one video. So it's going to be spaced out over a couple. But fans to look forward to in ones, and I haven't decided which fans I'm going to cover. Obviously these two in the box, and then which of the other open ones I'm going to do. So my Noctua NF A1215X15, sorry. The Lian-Li Unifan SL INF 120, the Noctua NF A12X25, the ROG Strix XF 120, the Cougar CF V12HP, and the Noctua NF F12. So I'll feature one of the new ones in the video with a couple of the older fans that I already have, and so it'll be spread out across a couple of videos. And let's go on to the next section where I talk about my test setup. Right, so this is my test methodology. So originally I was going to use a simple streamer test, so this would be blown in the wind, but after doing a few light tests it wasn't working the way I want. So I am looking for suggestions on smoke generators, just to be able to blow it through the fan and see how the air patterns come out of it. Because for best performing fans, you want to come, in my opinion, just straight out the back of the fan and not shoot out to the sides at all. Mind in pressure applications, fans that blow that way are fine, but for general airflow applications, it's not advised. So my main test then for how I'm going to be checking fan performance is with basically this box. It's a simulate for a case. On the bottom here, I have markings for different positions for my anemometer airspeed gauge here at the back. At 6 inches from the front of the fan, right there, at 9 inches, 11 inches, and 14 inches. My the 14-inch mark is a representative mark for kind of an average full-size large PC case, like the Fractal Design Torrent or Corsair 550D or something like that, where the cooler would be positioned as opposed to where your front fan is, at about that 14-inch mark. So that would be the front of an average air cooler. The 11-inch is more like a mid-tower case, something like the Fractal Design Meshify 2C2, the compact size one that can still handle ATX motherboards, and starting to look at more MATX size cases. And then the 9-inch mark represents short cases, so very short. So and then the 6-inch is very, very short cases. So that way you can see how much airflow it actually matters. And I have the fan going, and well, you can see my laptop screen. It's pretty bright in there. All right, so you can see the anemometer in there spinning away, and it looks like it's going at 0.7 miles an hour. I'm not sure what I have it set at right now. This is just for demonstration purposes. All right. For the real tests, I'm not going to be using a little battery bank. I have a wall plug, but I will be using this Noctua speed controller, as I don't have a spare PC to control it that way. It is one of my goals for this kind of testing. I have to redo testing on the fans. If I get a computer to run on this, so I can do more accurate incremental steps as opposed to twisting the dial, measuring the RPM via a laser thing. and basically getting it that way. So eventually hoping to get higher accuracy out of this. So the advantage of doing testing this way as opposed to a lot of other tests that I've seen out there where they create a enclosed chamber with a small opening in the back, where that gives you a pressure, basically a pressure versus air velocity curve, or CFM. So that's the amount of volume of air the fan can push. This is going to give raw RPM numbers. So this is actually how much air the fan can get through the case. So it's more of a real world test as opposed to a scientific test. Both are very valid. Both have their advantages and disadvantages. But since we live in the real world, I decided to do my testing as though this were a real PC case. And it can handle a variety of different fan sizes. Right now it has a 120 millimeter fan cutout. I have a box for 180 and a cutout for a 140. It can handle probably a 200 millimeter fan. So again, it's more like a real world test. So the front is enclosed here. You can see it right there. So that no extra air is getting through there, and the front is just completely wide open. So that the fan's interaction with its surroundings is sort of more like how you'd see from a case. The one disadvantage of this is you don't see how multiple fans interact with each other. So most cases don't have one fan in the front, and it's not hovering somewhere in the middle. It's either top, the bottom, or you could put it in the middle. But you would probably have two fans in the front. How would two fans interact? I can do a light test where I use a bracket mount and have two fans kind of floating next to each other in the 120 millimeter size. But at 140, you're starting to approach essentially filling the volume, where it's more like how the 180 will interact. So 180, basically the full volume of air is going to travel through this. And right now I don't have the backside sealed up. That will be taped up closed. So not 100% real world, because cases generally have more open slots than this will have. While this has a acrylic side panel, so it's easy to see through, acrylic on the top, and then just it's made out of cardboard and wood and cardboard on the back. But I think it's sufficient for testing fans. Hello viewers, I need to insert a new section into this video because I've already started doing my fan testing, and I have a few changes that I am making to my testing methodology that I had just previously stated. First, I have moved my test setup into my office so I can use my desktop sitting behind my test box right there, and the motherboard fan header in the PC to control the fan. So I have added 3 of Noctua's extension cables, 4-pin style, so that it'll reach around to where I place the box, basically. So I may have some power losses or instabilities from using so many extension cables, but in reality it should be relatively minor. I have no other way around doing this currently. I don't have a spare PC that I could literally just mount on top of it and run a very short cable run. So this had to be done this way. So this was done because the tachometer that I featured in one of the other videos and showed off previously, I was getting very inconsistent readings, and it was very hard to get the readings accurate. So I am using the tachometer readings from within the desktop itself that the BIOS reads in software on the computer using fan software in the computer, in the Windows. I also, because of moving it into my office, I lose a little bit of my noise floor. My office is fairly noisy with the computer running. I have a NAS in my office sitting, and I'm next to my wife's office, which a bunch of bathrooms below it in the house. So before every test, I'm calibrating my microphone that I'm talking into right now before each test, and I subtract out the decibel reading from the microphone to get as close as possible to the true fan noise itself. And I also place the microphone basically like that, right next to the fan, so it's picking up as much of the fan as possible. Now, in reality, you're going to be sitting farther away from the fan, it's going to be inside the case, so you're going to hear it less, but the values will be true for all the fans because of consistent placement. My mic, as you just saw, is a stringing mic, so it's not specialized at picking up noise levels and decibels, but it should do the trick close enough for my limited testing capabilities. It is what it is. I'm a small channel, very small, tiny, I'm minuscule, to invest in the best equipment out there. So this is what I can do for my fan testing. This is what I can do at my scale. I would love to have expensive pitot tubes that sit inside the box. I would drill holes either in the top or the bottom, and I place them at the marked lines in the bottom so that I could have as accurate as possible at the different speeds. And they would just live inside the case, and I would just pick up the readings from each one all at once rather than having to move my wind speed gauge anemometer from place to place within the box. That is just too expensive for my small channel. I would also can't do radiator testing or static pressure testing. I just don't have the equipment for it yet, and I don't own a radiator. So it would just be a high investment cost for this channel that I'm doing basically for fun right now. I do plan continue fan testing. Please comment below as to what fans you would like to see, and I will go ahead and try to get a hold of them and run it through the test suite. I've also decided to add CFM testing for fans. I bought some tubes. I don't have them yet. They're on the way. So hopefully one of them is large enough to hold 140 millimeter. It's hard to find essentially a PVC pipe, a ducting pipe in that size. I found a bunch of 120, so at worst case scenario, I won't be able to test anything larger than a 120. But most fans on the market are 120s, but I'm not really sure what sort of differences we're going to get going that way. But I've decided to add that to my testing. I'm pretty happy with my airspeed measurements, but I felt I needed to address CFM, mainly because the 140 and larger size fans move air more slowly, but they move more of it at once. I didn't picture it before. I'm using this heatsink to do my simulated radiator and CPU cooler fan test. So basically, I only have one fan in the front, and I hold my anemometer in the back, and I get the airspeed. I will completely remove these two fans. I slow the front two fans to the absolute minimum. I slow the bottom fans to the minimum, and these fans completely off. I'm not measuring temperature because there comes a point where the air going through the fin stack is so fast that you're not able to extract any more heat from it. Now, I don't think that actually happens with one fan, meaning for this radiator, I think would happen with two. But that's why I'm not doing that sort of test. Also, I have no experience currently with setting a consistent heat load on the CPU, and I would want to hold that as 100% consistent as possible, so instead I'm just doing airspeed. Otherwise it would be basically a test of more the radiator than the fans themselves. And lastly, I wanted to talk about what all this testing has entailed for me. Each fan takes me about 45 minutes to test because I install the fan and move it through 4 locations, have to read the readouts, write it down, move the anemometer to each spot at each percent or RPM rating. And all that takes time. And then unplugging my I just knocked my microphone. The fans on my radiator for the CPU and doing those testing. So it is just a lot of work to do these fans. And then it takes additional time for me to make the graphs and charts that are in the data tables and as well film everything going on with the fans. And setting up the equipment to get the decibel readings and all that kind of fun stuff. With the number of tests that I'm doing, plus reducing the noise, fan noise, room noise, this is a huge time investment for me. I've tested 8 or 9 fans at 45 minutes each fan. It's just a lot of work. I do plan to do more fan testing. Please comment again as to what fans you would like to see. New, old, expensive, cheap. This is a labor of love for me. I have always been interested in testing out fans, and no one seems to have a huge collection of data on fans, and I'm hoping to be able to build some of that up. So again, it's a labor of love. I hope you all enjoy the upcoming videos, and let's get back to the regular part of the video where I wrap up talking about the testing. With doing these tests, you cannot directly compare the different fan sizes for pure accuracy. So a 140 millimeter fan shouldn't be directly compared against a 120 for how fast the air is moving through this, because a larger fan is going to just fill the space more and potentially move more air through it. But they're all going to be listed on the same tables, but they're not necessarily directly comparable. You also cannot directly compare my data versus others' data because I'm not directly testing pressure that the fan can generate. I'm going to do a second set of tests where I run the fans through my Noctua air cooler in either a push or a pull configuration, and just see how much air velocity is at kind of the back of that. And that'll be as close as I have. I don't have a radiator at home to be able to test how well it can actually do with a radiator. So the best I can do is a simulate. And I figure that the Noctua cooler on my CPU is a larger one, thicker, compared to the double stack that you see on other Noctua coolers, so that it should better simulate how a radiator will do, because there's just more material for it to push through than one of the double towers, than the thinner ones. Again, the goal of this test is to be semi-realistic representation of airflow through a true case. You cannot directly compare the different fan sizes that I'm going to be testing with my various cutouts. I'm going to paint them and make them look nice for 180s, 140s, and 120s, because each of the different fan sizes moves a different air volume of air at a different velocity. So you could have a 180, a 140, and a 120 that all move the same volume of air, so that's CFM, volume per unit, so per time. Same volume of air, just for simplicity's sake of saying it. But the 120 has to work a lot harder to move that same quantity of air at that speed. So it's going to be moving it faster than a 180 moving the same volume of air at that's essentially moving at a slower velocity. So the data won't be directly comparable, but you can sort of gauge it, and the reason for that is, again, the wind speed gauge is just kind of sitting there off in the middle, so not everything is 100% comparable. To accurately compare different fan sizes, I would need multiple of each fan to approximate a larger size, so a couple 120s to get sort of more like a 180 to fill the volume over here for the amount of air it would push through. So there's real advantages to doing a test like this as opposed to just doing pressure curves versus airspeed that you can get with other testing. Because we live in the real world, I think that this has an advantage, and this is the way I've decided to approach testing fans. If I want to do a pressure versus air velocity, I need to enclose the back and have a fixed diameter there, and adjust the opening size at the back to have to know how fast the air is moving out of it, and that would give me the like true pressure versus air velocity distribution that a fan can generate. And to do that, you need to know the exact volume that you're dealing with. So that leads into the disadvantages with doing this type of testing. It's not true fan performance that I'm testing. I'm testing the air velocity of the fan going out this empty box with this wide opening in the back. It's not that real pressure testing that you can get by doing real computational fluid dynamics. So this is basically quick and dirty, easy testing that is easier, what I think, for just the everyday person to understand than the fancy graphs. And so that's why I've approached it this way. It was just easier for me to set it up and doing it on the inexpensive side and that kind of stuff, since I'm still a very small channel. Additional testing that I don't have in front of me, I'm going to hook each of the fans up, well, the 120s and 140s, I think I can get it to work, in front of my air cooler on my computer. The air cooler is a NH-U12A, so it's a thicker single tower heatsink, basically, tower. So Noctwood makes double towers, and they make that thicker single tower, and I don't have a radiator. So I think using that single thicker tower will kind of give me that better in-between point for demonstrating how well one fan can sort of push the air through it or pull the air through the fin stack. So it can sort of halfway simulate a radiator or a tower cooler. So that way I can get the air velocity coming out of it and get some numbers that way. Again, it's not perfect because I don't have a radiator, but measuring air velocity, I think, is the most reliable way of testing the fan's performance, as opposed to, again, doing the pressure velocity, or CFM, curves. And CFM stands for cubic feet per minute, and there's also meters cubed per second. So it's just whichever values you want. And I haven't decided if I'm going to do English or SI units. I do live in America, so I think in inches and feet and stuff like that. But SI is so much easier to work with. So again, I haven't completely decided what I'm going to use. So I'm just declaring that right now, but I'm giving my general methodology of what I'm going to do. And then after I have all that testing done, so again, I just drew up basic ideas, models for what I wanted to do. I'm going to generate some graphs and fill in data and get some nice graphs and charts out of it. So this kind of testing is something I've actually wanted to do for a long time. I love data. I am an engineer, and I do have a background in computational fluid dynamics, but I wanted to be able to present something in a way that's quickly and easy to understand. I think CFM versus essentially pressure, so millimeters of H2O, is perfectly good testing. It's like the holy grail. But I want to be able to test the fan at different RPMs, so different air velocities through the case, at different distances to represent different size cases. And I'm going to be generating a lot of data for the fans, basically, because each fan is going to be in 1, 2, 3, 4 locations at as many RPMs that I can figure out on doing on that little controller. And then plotting it all out versus it's decibel reading. So I'm going to have decibels versus RPM. I'm going to have air velocity versus RPM. I'm going to have the air velocity, RPMs, distances. So it's going to be a lot of work for me. And I'm really looking forward to doing this kind of testing. It's something that I love. And I hope you all look forward to seeing this testing and all this data. I'm going to do the same sort of thing through the radiator, the different RPMs, the different air velocities, not the distance part. And there we are. I have a whole bunch of fans that you all saw at the beginning of this video. And we're going to be testing them out. And I've got a whole bunch of other fans that are coming in. And we're going to just be filling out this data as I get it through. Anyways, thank you very much for watching. I hope you're as excited to see fan testing as I am. And have a great day.